All right, guys. Good evening to all of you. We are live, and yes, the screen is also visible. Okay. Let us see if the screen can get a little more. Uh, is it clear? Can you all read it? Let me check on my phone. Yeah, the font is really decent. You can read this. So we all have the all-in-one document. Let me just quickly check it up if the Git repository is uploaded successfully over here. Resources, yeah. We have GitHub Python 037 document AI. This repository is live and it's available to all of you. Let me go back to my live chat. Okay. Cool. Perfect, people. Now let us resume and let us understand what we're doing here today. Okay. So the goal is to also cover a bit of day two, and day two is focusing more on understanding how we can use the OCR capabilities also as an add-on to the document extraction. Along with that, how we can build an end-to-end RAG pipeline. Okay, and how does it work? So I will explain you how RAG works. I will explain you everything about generating the embeddings and making up your RAG pipeline work as a question answering module. Okay, so welcome and good evening to all the people who are live in the chat right now. I can see your messages. All right, so let us quickly start off with where we left yesterday. So yesterday we created a data folder in which we put in some PDFs. Okay, now I collected a few PDFs which are related to heart health. Okay, like one of this PDF is heart health. It takes up few of the documents like this, some facts about cholesterol, blood pressure, what is HDL and LDL, okay, what are some safe limits around it, how to monitor cholesterol. This is yet one more PDF that we were able to find, and what is blood pressure, high blood pressure, and what is IBP and impact of it on health. Okay, so these are few documents that I was able to find. Now we will be running through these documents when we work. I also created one more folder by the name of images where I have taken few images. Remember, these are not text, these are images, and we will have to extract text from these images. Okay, that is again one idea. Yes, so Sumit is saying that we are all ready for day two. Himanshu is here. Okay, now just a disclaimer: I take my feedbacks, I take my the methodology in which I teach very seriously, because I want to be someone who can help the community back. So I'll give you one disclaimer to all the people watching this live. Unintentionally, especially in this session, what has happened is I accept that I have made this project a bit industry standard. Okay, this is not a welcoming project to the beginners. That is what something I'll admit. But what will happen is that if you are a beginner and you actually have an opportunity to see such a project, I think this is really great stuff. Okay, there are two ways that beginners can take it up. One is be discouraged that this is too much, or else generate that spark that this is something that I want to learn, this is something that I want to achieve, and you're getting a really good industry standard code as takeaway with you. If you remember, the all-in-one document now has the Git repository. It contains all the images which I'm showing you, all the PDFs which I'm showing you, the module 1, 2, 3, 4, 5, 6. Everything has been updated in that Git repository, and it is publicly available. You can just simply clone that repository, put it on your local, spin it up with the requirements mentioned here. Just make a virtual environment, create a Git sample where you will upload the Google API key. Okay, this is just a dummy key that I've shown you over here. You can put anything in this, not just anything, your API key, and you're good to go with this. Okay, so now that we have the output is nothing but chunks. So remember, yesterday we were able to cut chunks, right? I've also improvised a little bit how we do chunks, but this is how we are doing it. So you see, ID is the PDF ID. Okay, so I have 3 different PDFs. So all different PDFs are highlighted over here, and this is the text, the chunk that we were able to cut out of it. Okay, and along with that, we are also storing metadata with each chunk. So remember, each chunk has metadata which is like how many characters are there, on which page number it is, what is the document ID, things like that. Because we will use this to give some evidence to our chunks, okay? That when we were chatting with our chatbot, and if we have to give a proof that from where do you talk about, so we can give the metadata that on page number 1 on this line we were able to find this answer, and this is the backing proof I'm giving you, okay? So this output is something that we were able to generate yesterday. If not, you can quickly spin up your module 2, okay? Module 2 does this part for you, okay? It generates this schema. Remember, I just showed you ID, text, and some metadata. This is what output of module 2 was yesterday. When we take forward with the module 3, the first thing is you will see that the very first thing we are doing here is we are importing a few things. Okay, so import SYS. This is a built-in module, system specific parameters module of Python. Okay, what it does is it is usually used to run some commands which we run in the terminals. Okay, it can help you run these commands. So we will quickly spin it up and install phase, which is the vector DB sentence transformer. Okay, again we will use this. So these are Python libraries. Okay, phase CPU is used for people who do not have GPU. It is a Facebook AI library. Simply that's it. Facebook AI FAI. Okay, that stands for. A dash CPU is for, it will not use GPU. Even if you have i3, i5, i7, it will spin with that. So sentence transformer is again a very easy to use embedding generation library, which is free of available. It is a transformer based model. You can skip it if you're planning to use Gemini, but I have given you both the ways. For people who do not even have access to Gemini API, you can simply use sentence transformers. You're good to go. So TQDM is again a utility library that just simply shows you progress bars. So whatever you see in my notebooks, that loading percentage and everything, it is coming from this. It simply create bars for looping things and see how progress is running up. Okay, it is more useful when we run things which can take up to few seconds, so that progress bar is much more visible. Again, talking about the next cell, I'm just loading up this libraries. I explained you typing would be useful for declaring syntax in our code much more readable. TQDM is again that I told you it is useful for notebook visualizations, graphics. Faz, we are using it for generating the CPU, but we will use Faz CPU for this time. Okay, so we will handle different environments. Have made this code more generic so that it feels less and works on many of the laptops. So we will just simply take it off like this. Okay, we have Python 3.12. Things are working fine. This is something, students, that you will have to configure if you want to run this project. One is the input chunks. So where are the input chunks? So if you have successfully run module 2 till yesterday, which you might not have been, no worries. You can just follow up with this pace right now. You can run module 1, module 2 later on. Or maybe right now if you want to run, you have the access to the repository, you can do it. There's a question, how we create a model like Stack. How do we create a model like Stack Overflow without any API? Anybody have data set of Stack Overflow? Well, that's a really good thought, whatever your name would be. The idea here is that you can try to use any LLM, okay? Try to write a web crawler, okay? Try to write a web scraper along with it. Search all different threads on Stack Overflow. Try to find different question answers. Maybe you want to do something with NumPy, you want to do something with Panda. So one idea would be, I'll give you one idea how you can do it. Go to Panda's official documentation, okay, and find all the functions that Pandas can do. Along with each function, search Stack Overflow with it, okay. All the URLs that you were able to find in Stack Overflow, extract the problem statement and answer from it. Then you can create a training data set of solving coding problems for you, okay. Then take up any base LLM. I would say that go for any LLM which is good by default at coding. For an example, Qwen. Qwen is a good large language model, open source available. Okay, download it and then fine tune it at your level, which will be really challenging. Okay, hi Akhil. So this will be really challenging because to train an LLM of that extent would be a large project, but for fun things, or maybe just to prove your point, to get a proof of concept, you can try this strategy and train it on very small sample set. Okay, use maybe low rank adaptation metrics, LoRa, Q, LoRa. You can try to use these techniques, these methods to fine tune a smaller model and publish your hypothesis on internet, okay, or maybe wherever you want to publish your study, so that you can also in fact try to publish the study to some you can say investors or to some universities who can sponsor you a few lakhs of rupees to get a GPU and then train your full-fledged project. Okay, so that's one way to do it, Akhil. That's my idea, which I will give it to you. Next, talking about configurations in this project. So this will be really interesting, people. Where are your chunks? You will have to specify it. Remember, if yesterday you were following, I kept data in the day one folder, right? So I wanted to use it as a common folder for all day one, day two, day three. So I moved it out. Hence, I'm using double dot now. I'm just adjusting my directories where they are. Okay, and with that, I am. If the directories do not exist, I'm making it. Now, what is my backend engine? This is really important, people. If you will not be using Gemini, put mini LM as the value in this backend engine. Batch size is fine. Text limit, you can move it. Even 1000 or 500 is enough. The character limit per chunk for embedding, okay, this is fine. The Google API key, which should come from your .env, okay. I cannot show you .env because it has my credentials in it, but .env sample is something that you can refer to and load something like this, okay. Now let us go back to day one, module 3. All right. So this is about configuration. All right. I hope you're able to understand this now. Now, what we will be doing is, I showed you in the data folder, we have this JSON-L which we created, okay? So we will load that, so that 16 chunks into it. I'll just simply try to print for R in range of up to 3. I'll print it and show you what different chunks look like, okay? So in fact, I just showed you even by opening the JSON that what it contains. It contains the file ID, number of pages, section, the text, and some metadata with it, okay? So that's about it. Now how do we create embeddings? So there are many different embedding models available online, one of which is mini LLM, which will run on, it is fast on CPU, zero cost, unlimited. You can run it as much as you want, but it has some limitations, okay. It only creates embeddings of 384 ka. So this is the metric size, okay, the size of your vector, which is a small scale vector. The more complex you want to make it, you can use more complex embeddings, one of which is text embedding 004. This model is from Gemini. There are some older models also, 001 with bigger dimensions, but this is a quick and easy model to spin off. So I've mentioned it that we will be using it. So people who will be using local model, you will run through this class. Whereas if I am using Gemini, because things will be simple, okay, both will have same functions, in initialization function and encode function. See, both will be same for both the methods. I'll just explain you one class. What does it mean by that? So for Gemini, what we are doing is, see, we are taking input as model name. Okay, of course, which model do you want to create with Gemini? So text embedding 004. Okay, do we have Google key? So assert is a reserved keyword in Python. It tries to confirm if this value is not null. Okay, so if null, it will throw an error. So we will assert API key. If true, we will move ahead. We will import the Gemini and Gemini.configuration. We will simply pass the API key. Remember, this is a standard way of setting up Google Gemini in your Python. Okay. Once this is done, we will create an object, self.Gemini, self.model name, and self.dimensions. So if people who are familiar with how to write classes and objects in Python, this is how you do it. So we will create the Gemini object with the model name and dimensions. Next is the encoding. How do you want to do it? Okay. So I told you TQDM is a library which is useful to visualize things in the output of Jupyter Notebook. So for I in this range, we will put everything in TQDM. We'll run things in batch. Okay. What we'll be doing is we will select each chunk. Okay. And this is the method, embed content. Embed content. And how we are doing it? We are running it from Gemini object. Okay. Self.Gemini is nothing but Gemini configuration. Okay. This Gemini object. We are running the Gemini object. We are passing the model name, and whatever content it is, we are batching content. We are passing 4 or 5 chunks all together. Okay. And the type of task that we want to do. Again, now this is straightforward. There is nothing to put head in here. This is how Gemini ka embed content method works. It requires these things. we are passing them these things. Okay, we are trying to make a retrieval document embeddings. Okay, uh, what is the input which goes in content, which model are we using, goes in the model. Okay, once it is done, we will simply return the embeddings. Okay, so this is about the class Gemini backend. Once we have done it, we will define a function to get backend. And if it is mini LM, which is the local version, it will use this. If it is Gemini, it will use this. If not, it will throw an error. Simply, we will pass backend through here. Remember, backend is configured in the, you can say, input, uh, indexes, and manifest. In this, I have stored the configuration. You just need to simply update it from here. If you want to use mini LLM, just write mini LLM over here, change the dimension to three something that I told you, and you're good to go. Okay, so you can use this simply to generate this embeddings. Okay, so once you run this, okay, where were we? Right over here. So once you run this, you will simply set up your embedding model. That's it. See, output is what we are using Gemini, model is what, and dimensions we have set. Now we will prepare a text and compute the embeddings. Okay. So what does prepare a text means? It means nothing. We have stored text somewhere, right? We will just simply read it and put it in an array. We will normalize it. Okay. And this is what text is. Text can we will pass chunks. We will create embeddings of what length do we want, and dot encode. Remember, dot encode is the method we just created in the previous class, which means now we will simply encode and create the embeddings and store the embeddings as normalized embeddings. This is all about it. So doc store will store all the embeddings, and if you run it, we are embedding 16 chunks, and this is the dimension. Okay, so 16 elements, each of 768 dimension each. All right. So I think all of you are following. No doubt still here. People, you can just quickly go and give us thumbs up if you're following. Any doubts, bring it up. Do not worry. Even if it takes 15-20 minutes more, I'll stay back and teach you everything. Okay, do not worry. Now let us see. We have embeddings now. Okay. What we did yesterday, we created chunks. What we did today, we saw how we can use Gemini or either the local transformers to create the embeddings, which are nothing but vectors for us. Now let us create a vector database, which is Facebook AI similarity search. Okay, the FAISS, the phase of it, right? So to build phase, we will simply import the library phase.index. This is the library which we'll use. Okay, and we will create a function to save it. Okay, so where do we save it? So we have our output directory /index.phase is where we will store it. We can also save it in this format, is a NumPy format. Okay, we can save the manifest file also, which I just showed you is something which is our setting files. So in manifest, what we store, what backend was used, what was the dimension of this backend, how many counts of embeddings we created, and when was it created. Okay, so if you remember, this is what my manifest file looks like, and the reason we are doing it is for reproducibility. Okay, with minimal changes, all your module 1 2 3 4 5 6 should run. Okay, so if you check throughout my code, you do not need to change a lot of things. Okay, you just need to do some settings which are in data and some settings in each of the notebook, but rest of the code is reproducible. Wherever you want to run it, you can run it. Okay, yes, there are a few places where I have hard-coded things which I should have removed to make it more reproducible and more scalable at some point, but I will show you where those problems are, and you can fix it at your own. Okay, these are easy fixes. So once this is done, we will create a function to load the database also. See, we just create a function to save the indexing. So to load, what we have to do is, if we have to save something, we do save index. If we read, we use .read index. And from where do we read it? Again, the same input directory path. How do we load the vectors, and how do we load these different files? This is it. Very simple, people. Okay. Sir, when we use ML, is this store only limited information in its vector space? Shivam, can you reformat your question? Okay, I might have not understood it correctly. So index, this is the build phase. This is how we build and then save. Okay, and then you have to reload. We can reload it to verify whether the load function is working or not. Okay, so in the output, if you see, index is saved to it. In the output, you can see reload index is loaded from here. Okay, so this is as simple as that. Nothing fancy over here. Not at all complex. Just a save and load function. Now we need to create search utils. Okay, so one is to embed the query. remember people that suppose I'll give you an example. Embedding, what is embedding? So we are converting these strings into say an array, okay? Strings into some numbers. So any character like A, B, C, D, each is converted into some numbers. So if I'm asking a query, I cannot ask it as a string and search in numbers, okay? I'll have to also embed my input. So if I'm asking, hi ChatGPT, how are you? Or hi Gemini, how are you? This string also has to be converted into the same embeddings. So what I will do is we will use the same encoder. Remember, the encoder has to be same which was used to encode your embeddings. Okay, with the same encoder and the same normalization technique, we'll simply use embed query, which is our function to convert even the question now we will be asking into a vector space, so that now we can match vector with vectors. Okay, search phase is nothing but this is a built-in method of phase. We just need to use index.search. In that we need to find we need to pass query vector. What is query vector? This is the query what we are asking. So whenever you use ChatGPT, whenever you use OpenAI, Gemini, or any LLM, whatever question you're typing, it goes over here, okay, in the vector search. Top K is it will return, top K is, you can say, a hyperparameter. By default, if you see, I'm putting in a value of 5. What does it mean? Let us see if any of the student can put it in the chat. How many of you know, or how many of you can say what is top K over here and what does top K do? Quickly, one line if you can put it, I'll know that any of the student is able to answer this. Let us see if any answer is coming up. Let me just quickly also refresh my chat. All right. So let me also meanwhile answer this to you. If there is any delay in the answers coming in. So top K stands for the top 10, and like K is a number over here. In my case, if it is 5, so top 5 most matching vectors that I've found in my knowledge base. Okay, that's what top K stands for. So that's the idea about what top K is supposed to be. Let us see if there are any people who might add some value to it. If anything that you know, people, you are more than open to answer this. Okay, let us see. Anyone? So again, the next part from here is we will be using an MMR re-ranker. What does it do is, so suppose I have found this 5 matching, you can say, parameters, okay, or 5 matching vectors. The next part from here is how do I make sure that I am loading the most accurate ones, okay? So here, re-ranking algorithm could be used. MMR stands for maximal marginal relevance. So from this top 5 results, we might again go ahead and now pay attention to these 5 results, which is the best one to use now. Okay, so suppose if I have to I'll give you one analogy how to understand this. Suppose I ask Google that what is the difference between an LLM and a vision LLM? Okay, now Google will give me search. It will give me search of hundreds and hundreds of URLs which are matching to my query. Now it has given me top 10 results. Now it is my human choice, just by looking at the glimpse of it, which URL do I want to use, which URL do I want to learn from. Okay, so our search similarity function will return us top matching results in our vector space, which have the capacity to answer our question. Now, re-ranker algorithm here will decide which one is the best to choose from. Okay, so MMR re-ranker algorithm, it is a pretty straightforward algorithm. In fact, you can just copy it from Google also. It just uses basics of cosine similarity and basics of mathematics to re-rank and rank the best available, you can say, the vector. Okay, so this is advanced rag, I'll tell you. Okay, normally when we teach, we never teach about MMR, we never teach about any re-ranking algorithm at all. For students, we keep it very simple. We simply keep it only till here, search space. This is what we do, and we simply blindly pick any one of it. Okay, but I want to make it a more interesting project so that you can learn more. I've added a re-ranker. Okay, we want to explain you how re-rankers work, and this is how you will work. Okay, this is how you will use. Now, to just compile this entire pipeline, query, we will convert it into query vector. We will find the dimension and indexes from search function we made. And from it, we will re-rank it. And from the re-ranking, we will have a final index and dimensions of vectors we want to use. And based on the score and the metadata, we will return results. Audit, a very straightforward method to create a search utility. Okay. Once this is done, now is the interesting part. Can we try some queries? Okay. Now remember, people just go through these documents what we are using. So okay, we are using some PDFs, heart health. Okay. What are some interesting things it has? It has a few interesting things right over here, right? Don't smoke, engage in physical activities, keep blood and glucose level healthy. Some things about HDL or LDL. I don't know what these things are, but okay, here it is mentioned high density lipoprotein, low density HDL is good cholesterol, LDL is bad cholesterol. Okay, increasing age is also a heart factor, something related to blood pressure, cholesterol. Okay, then these are documents which we have. Okay, things right here. So now what we will do is, since we have created the search utility, we can simply use it to match certain vectors. Okay, so how we are doing it, just go through this function once. I have created some samples which are like certain queries. For each query, what I'm doing is I'm using my search method, which I just created. So for search method, I'm passing the query, I'm passing which backend I want to use, which store I want to use, which vectors, and top KS3. Do I want to use MMR? Remember, students, MMR is more useful when your queries are large. Okay. Uh, just passing simple word like age or cholesterol will not do magic for you. But if you put it true and you run it from real queries, it will also show you the magic. So for now, if you see my query is age, I'm running it with MMR. Okay. It is giving me score. It is giving me which PDF, what is high blood pressure. Do I have this PDF with me somewhere around here? Yes. What is high blood pressure? See, this is the PDF name. Which page number? Page number 2. Is there any section details? No, for now. And this is the vector it matched. And similar to it, HDL, this is the query. So it is trying to find things like that, high heart rate, cholesterol, things like that. Okay, plant-based proteins, something like that. So it is working for me. Now I'm giving a mini task which I've also solved for you, which is like, can you actually build something like a search retrieval engine? Okay, so for it, we will use Gemini for answers. Our backend will be Gemini. Okay, and these are some prompts that I'll run through it. Okay, and we will use generative AI to generate content. Okay, and remember, we are passing these things to it. Okay, we are configuring these things which are already available with us. Okay, so how Gemini will work? Look at this if loop correctly. Okay, so what is my question? What does the term HDL mean? Okay, we are printing answering with Gemini Q. What is top? It is the search. So search is our entire pipeline in which we do this searching. Okay, and what is answer? Answer with Gemini is this method. What is answer with Gemini? So answer with Gemini is where we import GenAI. Okay, we configure the API key. Okay, once we've copied it, we will create a prompt out of it that you are a helpful assistant. Use only provided context. See, we are limiting the Gemini to not use its built-in answering method, but to use only the provided text to answer. You must answer to be concise and grounded with the provided text. Cite your sources in bracket like this. Okay, what is the context? So context is what we will find from the retrieval module. Okay, so for rn retrieved, and we are passing retrieved to this method. Okay, so this is the context and this is the question, and give your answer like this. And dot generate content is the function name that we pass with Gemini to get the answer. So similarly, top is our search. We are searching matching vectors, and answer is we are answering with Gemini, and then we are printing answer. Okay, so if you run with it, see answering with Gemini, this is my question, and you will see HDL stands for high density lipoprotein. Where is it coming from? It is exactly coming from our PDF, exactly word by word. It is same from our PDF. Okay, so this confirms that we are using the vector search and re-ranking algorithm along with it to get the answers right over here. Okay. All right. So I think this is cool. This is interesting, inspiring people. Any doubts in module 3? Okay. I'll keep the indexing and new chunks, how do you add it as a additional exercise for you? Okay. I hope you were able to learn how the importance of how we convert or how these models actually work. They take up strings, they convert it into vectors, store vectors into a vector database. See how we have SQL to store structured tables, how we have NoSQL to store not structured tables or no structured data. Similarly, we have vector databases to store vectors. Vectors are nothing but this numerical arrays, okay, which represent strings. Like English to Hindi we do, Hindi to Japanese we do. Similarly, string to vectors, vectors to string. This is how transformers work. Transformers need vectors to work with. That's how they work. So we will convert everything into vector, which is our knowledge base. That's what we call it. All our PDFs are converted into vectors, stored somewhere with chunks, of course, in pieces, in chunks. These PDFs are broken down into chunks and stored somewhere. Whenever a question comes, we use the search algorithm to find the matching vectors in our knowledge base. Once we have retrieved it, the retrieval has given it to us. We use an LLM to now generate an answer using the retrieved vectors and the input query, and that's how it works. Okay. So now the idea is if we can make it more complex, if we can add something into it. Okay. So module 4 talks about it. Image to text using Tesseract OCR. Okay. So Tesseract OCR is an classical OCR model, been here for years now. Okay. Many years Tesseract has existed. Again, I've given some notes how you can install it on Mac. Mac with simply brew install Tesseract will work. Ubuntu, you have Windows के लिए, you'll have to go to this link. When you go to this link, okay, if you click on this link, you will realize that it opens up the Tesseract ka default GitHub page. Okay, scroll down a little bit. If I'm not wrong, somewhere it will tell you installing Tesseract. You will find this thing. Okay, and there will be another link to install a binary package. Click on that link. Okay. And from there, you will be able to download a .exe file, executable file, okay, for Windows. You will have to scroll down on that hyperlink, okay? Just scroll down. For Windows, you will be able to find that Tesseract at UB Manheim. This is the. I'll also give you that URL directly over here also. Let me just edit it. Let me just edit this path over here. Actually, this is the direct path where you will be able to download it. Okay, if you just simply click on this link, you will reach this Git repository. Very simple. A link pe jate sir, you will find a .exe file. Install it directly into your C program files, Tesseract. Okay, that's it. That's all. For Windows, no more trouble. Okay, no need to worry about how you will work with Tesseract. Simply a link pe jao, click karo, download the exe, run the executable. Okay, setup ho jayega. Do not change where it is installing. Keep it simply on where it is, like this. C program file Tesseract OCR Tesseract.exe. Okay. If you're in Windows, you just simply need to run this command. So I've hard coded this command. Okay. So for someone whose C drive might be full and you want to install it somewhere else, you will have to change this path over here. Okay. If you're using Windows and your C drive is not working. Okay. But for people who are on Windows and C drive is working, no need to change this notebook anywhere. It will work. So this is a little bit about it, how it will work. In fact, I've given you updated URL from where you can just simply download it. Okay. Now with this thing, we will simply import things. These are no more, I'll say, things which are difficult to read or learn. Okay, simple, straightforward things. Okay, so this is a little bit about it. So we are loaded Tesseract. We will keep everything same. Remember, for each notebook, the basic configuration will remain same. It will not change at all. What is the OCR language? What is the some pixel densities, DPIs, how many characters to read? Okay, things like that. Okay, so if you see OCR language is English, because we will tell OCR that we are using English. OEM equal to 3 is like nothing but OEM is a mode in which the OCR will work. Like OEM stands for long short-term memory engine. It will use LSTM as the base deep learning architecture. That's what OEM3 would convert to. PSM is nothing but page segmentation mode. I do not need to go into this depth. People, remember, we are learning how to make document intelligent. Okay, we are not learning computer vision. We are not learning how Tesseract works. We are not learning how the LSTM or these networks work. These are some simple settings which will be needed to run Tesseract. Okay, sir, how can I get that link? So remember, in the all-in-one documents, I have uploaded the Git repo. Just clone it, and you'll be able to run through it. Okay. If you're talking about this particular link, this UB manheim, abhi screen pe quickly just take a screenshot. In fact, if you go to my notebook also, there's a link, but there's a follow-up link. Okay, just scroll down, installation pe jao, you'll be able to get it. Okay. And I'll push these changes. ये link में update कर दूंगा. Okay. So with that being said, these are few settings. Okay, I'll not invest time in explaining you how Tesseract works. Tesseract is a OCR model, ready-made deep learning model to extract things. Again, similar things. ये बस copy paste कर लोगे पिछले वाले कोड से तो भी चलेगा. Gemini का backend declare कर दिया. Same methods, how to get the backend. Okay, we are using Gemini in the backend. Now, these are few things that we are doing to improve the OCR accuracy. So if anyone over here has learned how to do OCR, you will understand the importance. First of all, convert your image into grayscale because colors can confuse the model. Upscale कर दो, image की scale थोड़ी improve कर दो, binarize कर दो, skewness हटा दो if your image थोड़ी टेढ़ी मेढ़ी है, tilted है, skewed है, remove it. Okay. So these are pre-processing steps which will run, and we will apply these filters on our image so that OCR improves. Okay. Anyways, I'm using some simple images. OCR accuracy will be good. Image to text. What we'll do is Tesseract का image to text model call करेगा. We will pass the image, the language, the configuration that we are putting to it, and we will simply get image out of it. I have given you more methods. अगर आप PDF to image करना चाह रहे हो, OCR image path, this is something that we will set up. Okay, I'm giving you some demo with some random images. If you are able to do it, we will create a complete OCR pipeline. Okay, once you have done it, what we'll have to do is we will have to remove some garbage from your images. Okay, so this is nothing but clean OCR text. Again, not a very important method to worry about. In fact, beginners को हम ये सब कराते ही नहीं है. There is no concept of explaining how to work with Tesseract, concept of how to pre-process, clean, post-process. Simple एक image लेते हैं, Tesseract चला देते हैं, that's done. But I'm giving you a little more depth. In real life, it is not always that you will get clean text. So you will have to write a function somewhere. OCR होने के बाद भी थोड़ी cleaning लगेगी. That's where this method will come into picture. It will remove the things. Coming back to chunks, no need to worry. Module 2, we have covered how to create chunks. Again, I'm using a very simple strategy. Cutting, now whatever has been extracted from the OCR, we are cutting it into chunks. We are running it into OCR and OCR image into directory. We are storing same format. Remember, ID kya hai? This is the image path. Text, whatever the chunk we got. Metadata, this is the metadata we will store with it. Okay, and we will simply return the records. This is for image. This is for PDF, niche wala function. So PDF I'm not covering, but I've given you a you can take it as a homework, you can take it as an exercise to also have PDFs with images. Okay, and then we will save JSON. Similarly, we will save JSON right over here. If you go to data, if you go to indexes, you will realize that we have everything mentioned in the doc store. Okay, this JSON. This will have in fact details like 3 images are now added over here, right? So this is it. So JSON contains all our documents. This is the PDF and how many chunks were created. This PDF, how many chunks were created. 6 chunks coming from high blood pressure, 5 coming from heart health and cholesterol BP PDF, single chunks coming from these images. Okay, so that's the idea right over here. Now, once it is done, you will simply run this module. When you run it, you will get the doc store updated. Okay, just the way we did it. Now, again, very similar thing. Whatever we did in module 3 coming up again. Normalize कर लो text को, fairs को build कर लो, load the index, save the index, same functions coming from the previous explained files, and this is how you will store vector database now updated with images. Okay, and this is the complete pipeline. ऊपर जितनी functions declare किए हैं, we are running it over here. Okay, you will see embeddings generate हो रहे हैं, indexes are updated, and now again to validate whether we are doing it correctly or not, we will similarly use embed query method, search method. Remember, students, since I have divided these notebooks into separate subjects, small subjects, there are many functions that I have to rewrite. If it was a Python script, it was a Python project, yeah, embed query, yes, search, even this method to create vectors, even this save index, these sare functions I would have reused if it was a single project. Okay, but to keep it individual files, I have reused explain you entire things. Okay, hence do not worry. It might look all these notebooks are so big, but they are individual notebooks to study one notebook at a time. Okay, so you can, and people who know it is simple. It's straightforward. Yeah, functions are being used again. We are again using this function, how to search and how to get the output of it. Okay, so if I have to search electrical impulse, okay, this is my query. Let us go to image and see if there is something like this. Fact, yeah, तो नहीं है fact. Okay, I think there must be somewhere. Let us see if anyone is able to find electrical impulse somewhere. Okay, because I might have tested these images somewhere and I might have find it. Okay, let us see if someone in the chat can help us find this electrical impulse somewhere. Oh, the very first image right over here. Heart has its own electrical impulse. It can continue to beat even when separated from the body. Okay, so you see, heart has its own electrical impulse, so it can continue to beat. This is the output we are getting. Okay, so if this was our query, this is the answer that we are getting, and how we are getting it. Now our knowledge base not only has inputs from the PDFs, but not also supports input from images. Okay, see, such a good project that if I search heart cells, you'll see that it is giving me the matching indexes for heart cells also. Okay, in something like in United States, heart disease is leading cause. I think this is where the heart cells word comes into existence. Now you can run your more interesting queries. You can play around with this chat as much as you want. Let us jump to module 5 now. Okay. Any doubts still here, people? Anything you want to ask? Any query? Even Shubham Kamate, if I am not able to answer your previous query, you can ask me once again what exactly were you trying to ask. And do not worry, you can take your time to answer, put your thoughts in chat. All right. So that's the bare minimum idea of how you are supposed to work. Okay. Again, what is module 5? Okay. So module 5 is where we are building RAG now. Okay. So user query bhejega, we will embed it, we'll search the vector database, we'll give these results to the large language model, and then get the output. Okay. So from templates, we will be designing it. We will be using RAG chain. So there are two ways to use it. या तो RAG chain बना लो या तो LangChain का retrieval QA chain use कर लो. Good thing is that I have shown you both ways how you can do it. Okay. The idea is we will set up our LLM. We will use it. Okay. Optionally, what you can do is आप OpenAI के साथ इसको try कर सकते हो if you have the API. If not, Gemini is good. नहीं है, मैंने इसको local भी बना रखा है, right? If you need any dependencies from it, just install it. Here we are installing everything. Let me comment it for now because I don't need it. But you can install it if you want. Okay. You see, I have installed everything, and once it is done, in index directory kya hai? See, I have hard coded everything over here. Okay, which is like just out of this folder you will find it. So this will work. These are relative imports. This will not trouble you. Okay. Now we will simply load our index, whatever it is, right? Okay. Shivam has put his question: is ChatGPT or other machine learning models store unlimited information in vector space? And please explain about the vector space in machine learning. All right, sure. I get your question now. So yes, even ChatGPT and other models, they also store all of their possible information in vector space. So whichever model you're working with, they are so good at it. आप chat GPT को poem लिखने बोलो, you write a story, do summarization of your text, search something for you, chat with you, everything is coming from vector space. Okay, so the idea of vector space is what? Okay, so if I give you so firstly, to understand vector space, Shubham, you have to understand that I teach you communication as a language. Okay, but I do not teach you the meaning of words. I just simply explain you that A, B, C, D, E, F, G, H till Z, these are characters which are used. Okay. उस mindset से समझना that you are not literate. You do not know to understand the meaning of a language. You do not understand the language, but I explain you what these characters are. Like I explain you that you just understand 1, 2, 3, 4. So I explain you that A is equals to 1, B is equals to 2. Now you will sit down and try to write whatever characters are in numbers, okay, in numbers, and then you will try to store more complex things. अभी तक तो आप सिर्फ ABCD सीख रहे थे. Now I will give you complex things. I'll give you words now. I'll give you hello. I'll give you hi. I'll give you a, the, in, are, you, am, something like that. Okay. Now you will also simply try to start giving each of this number a code word. Okay, like hello को आप 21 बोल दो, how को 22 बोल दो, is को 23 बोल दो, something like that. Okay, it is your personal dictionary because you understand numbers. I understand the language, you do not. But what you will do is, it is a very tedious and hectic task, but this is how machine will work. It will convert all our words. Okay, could be sentence भी हो सकते हैं, वो sentence level को भी हम एक number दे सकते हैं कि this sentence को convert करना है तो number में convert कर लो. So what it will do is, it will store everything into numbers. So if I'm telling hello to you, you will write 21. Now you understand 21. Okay, you understand that. इसको और आगे लेके जाते हैं. Now I will give you a complete book about engineering. Engineering में there are many semesters. In each semester, man, all subjects. I'll give you everything. Okay, I'll give you how language works. I will give you storybooks. I'll give you some essays, some documents. Language, बहुत सारी language मैंने आपको दे दी. Now you will try to put these words into a vector space. Vector space is what? Where you have magnitude as well as direction. Okay, so so if I have to put everything in vector space, all my neighbors and I, if it is a geographical vector space, we will be put very together. And whereas someone who is living in USA or UK or New Zealand, they'll be very far from me because vector works with locations also. So vector mein hoga kya? If I am putting hello somewhere, I'll first of all, so I'll just randomly put everything in the vector space, each word in the vector space. Now what will happen is, I'll try to make sense that I have seen many times while reading this text that hi, hello comes together. Will now start making sense. I'll start putting them closer in the vector space. Okay, then I'll start realizing that how comes very much common with hi, hello, how comes next. Okay, so this is how I'll start designing the closeness of words. And in the greater picture, you will realize now words like king, male, alpha, they make more sense to it. Not by understanding language, just by understanding the repetitions and similarity of these words, nearness of these words, the model will try to understand, okay, these are similar words. Okay, so remember, model is not literate in our language, but the model is smart enough to understand numbers, and from numbers it is smart enough to understand patterns in the numbers. Okay, where these numbers come together, how it comes together, and based on it, now it will simply use probability that hi, it will go back to its vector space, understand which is the next word which comes after hi, usually what I have learned, and pick up 4 or 5 matching words, use a probability to give the most probable number. It will say how. After how, naturally it will come R, naturally it will come U, it will come question mark. So it can keep on generating like this. So this is how the vector space will work, Shubham. I hope you are able to understand it at a very high level how it works. So we are loading our vectors, whatever we created, and then we are using any LLM backend, same function, repeating it again. Okay, so Gemini backend is coming here, same method. Okay. Now we will simply use, now this is the main, module 5 ka main part is right over here. Okay, LangChain core documents. Okay, so this is really interesting, people, because I like LangChain a lot. I developed many things with LangChain. In fact, Crew AI, OpenAI SDK, LangChain, this all 3 frameworks, I love them. Okay, and if you are a LLM developer, you should start learning them. Okay, they are really cool and interesting things. Okay, so let us start thinking and talking about these things. Okay, so the idea here is that LangChain has many built-in methods into it. One of it is document and one of it is retriever. So LangChain ka document kya karta hai? So it helps us load the text into LangChain compatible object. ठीक है? So remember Excel sheet के अंदर डेटा होता है, सिमिलरली पाइथन के अंदर डेटा फ्रेम होता है, सिमिलरली numpy के अंदर np nd array होता है. So these are objects of the classes belonging to that libraries. So LangChain के अंदर text को रखने का, like this is the object. Document is a standard LangChain data structure. Okay, it is used to hold text along with the metadata with it. Okay, that's morely about it. But if I talk about retriever, so base retriever is a simple base abstract class. It is used to retrieve vectors. Okay, that's what it is used for. Whereas Pydantic kya hai? So Pydantic is a very powerful library. It is used to declare your custom classes where you can explain the structure of the input or output. Okay, that's where it is useful for. So embed query, search, MMR rank, तीनों common. पिछले दो modules से we are using it. Okay, this is nothing but how you search and search a query against the vector space and get it. Okay, so what we are doing right over here is the Pydantic model. Okay, so we are explaining our key values like a class structure. This is the structure. Any configuration जो होती है ना in a class, you put it something like this, and this is how you declare it. This is nothing but our key values, our structure, how we are going to use it. A class will have configuration and certain functions. Get relevant document कैसे चलेगा? Everything is similar to what we have learned. Embed query, search, answer, and find the documents and return it. Okay, so this is our retriever that we have made. Now we are using Gemini. If so, we will be using Gemini. We will use this. We will use model. You can even use 2.5 models, 2.0 flash models. Temperature क्या करता है? Temperature sets whether do you want to use less probable tokens. जैसे high के बाद क्या आ सकता है? How आ सकता है? कुछ और. There could be anything that can come up, right? So if you are using temperature as one, model will sometimes try to do variations that hi bro, okay, or hi dude, okay, or hi how are you. So it can use different words if temperature is high, so which means that you can get a more versatile result for the same query. If you ask it to write an essay on India, it can write essay in different variations even if you keep on repeating it with high temperature. But when you want more factual and more straightforward and more repeatable output, more restrictive output, temperature को हम कम कर देंगे. What it will do is it will make sure that the model is using the most probable token only. So every time after high, if how has the probability, it will simply go with it. Okay, that's the idea about how the settings of an LLM would work. Now, once this is done, the next idea is that we will use the OpenAI key. We will set up our OpenAI model if at all you were using it. But we will not go over here. We will simply use the if statement, which is the Gemini key only. Okay. How to declare a ChatGPT model, I've also explained in this project right over here. Okay. Now, once this is done, we will use LangChain ka custom chaining prompt. Okay, so what are chains in LangChain? So LangChain, the most important asset over here is chains in LangChain. Let me quickly explain you what the chains in LangChain are supposed to work. Okay, so LangChain can help me do many things. One is to write a prompt. Okay, other is to load an LLM. Other is to generate a response. Other is to do a function calling and many things. Okay, so these are known as LangChain expression languages, LCEL. Okay, it can help us. There are many helper functions which you can use. So one is to create a prompt template, one is to run through it. So it will help us create even for the output, it can help us do things. So we will be using prompts, we will be using a running template, and we will be using a output parser. Okay, so that's the idea about it, what we will do. So structured parser will always make sure that the output of the LLM is not something that we get on a regular basis, which is on chatgpt.com or gemini.com. Okay, it is more according to our JSON format. We will define always response like this. So it will always respond like that only. So first of all, we will collect all the documents. Okay, we will put in the prompt. Just see a simple prompt that I have put over here, that you are a simple assistant. You only use the provided context. Always cite it, be precise, and avoid speculations. This is the format you will use. Okay, and this is where the LangChain comes into picture. What is the first thing? Remember the pipe operator. The pipe operator is the most important thing in the chainables. So it is in the sequential order. Okay, whatever is in the first place will run first. Something after it will run second. Something after it will run third. Very first thing that we are doing is we are passing in the context. Second is we are formatting the document and the question. Third thing is we are putting in our prompt. Prompt uses question and context, remember. Fourth thing is we are calling our LLM. And the fifth thing is we are structuring the output. We have just declared the chain for now, how it is supposed to work. So what is the first thing? First thing is you need the context. Second thing, question hello. Third thing, put it in the prompt. Fourth thing, pass it to the LLM. Fifth thing is format the output. So this is the chain. Now, how do we test our RAG chain? Okay, so the idea for that is that can your heart beat outside the body, or what is the full form of HDL? What is the impact of lifestyle? These are a few questions that I'll ask, and you will realize that hey, the model is working really fine, and I am just using RAG chain.invoke. Remember, now I need not write all of things again and again. I have just compressed everything into a RAG chain. Okay, so LangChain is especially good at it. You can explain one time what it's supposed to do. It will start with the input, okay, which is the question coming right over here, and run everything for you. Okay, so for each question, it will simply give you the output of the chain. So that's about it. Now, with that being said, I think this is the idea how the LangChain will work. I'll similarly also give you another method to do it, which is to use Retrieval QA chain, but I'll not explain it. I'll give you as a homework, okay, which you can take it right over here. So how many of you were able to set up this environment? It can take some time, but take it as a challenge, people. Try to install this project, try to run through module 1, 2, 3, 4, 5, 6. Okay. So you have a lot of things. If you are a college student, or if you are not, you might still have to invest 2, 3, or 4 hours before tomorrow's session. Okay. So before coming up for tomorrow's session, you will have to make sure that you have run through all this notebooks, especially day 2. Day 2 is very important, because day 2 ka idea was that we needed to cover how OCR will work and how we can generate a RAG module. Okay. Now, I understand it is too much to bite. Okay, if this was a college lecture, if this was a college session, I would have taken at least 5 days to explain you module day 1, another 5 days for module day 2, and another 5 days for the day 3. Okay, or even if it was you can say a YouTube session in which I would have explained these things, I would have taken at least 12 hours or 8 hours or 6 hours of video, to at least 12 hours of video to cover this syllabus. Okay, since this is a boot camp, I have taken it up to a marathon level to cover things. Okay, see, the idea of this session is that I'll continuously keep on speaking. I'll keep on speaking just to explain you once what this code is. What is your takeaway is that you will take away this code and you will have this recording forever with you. Okay, I've explained you things over here. Run them parallelly, learn them, and master it at your own pace. Okay, you have the code with you, you have notes, you have the recorded lecture. Come back whenever you want and learn through it. The benefit that you can take from here is we are live in the chat. So you can ask me if there is any intermediate doubt. Do not refrain if you feel that this is too vague, or it's too silly to ask. Nothing is too silly to ask. Okay, just go ahead and make sure that you have all the clarity that you want. Next, module 6 is all about agents. Okay, now if this was a class about agents, I would have explained you what AI agent, what is the concept of AI agent, but let me quickly cover it. See, the concept of AI agent is that you can give AI some tasks to do without much interference. Just give the task and the agent will take it up as its responsibility. It will take up autonomous behavior and run through whatever is needed to complete that goal and complete its goal as the end output. Output of an agent is it completes a task. That's what an AI agent is supposed to work. So now what we will do is we will see how AI agents work with a reference to our RAG, how we can add up memory into the LLMs or the agents. Okay, if you want to realize even at this point, then think about it that whatever we built till module 5 is only capable of answering a question. It is not capable of doing a follow-up question. Okay, so for example, if I ask the LLM that give me 5 important points to take care of my heart, it can generate an answer. It can give me 5 points to take care of my heart. But now if I ask it another question, explain a little bit more about point number 2, it will fail, because it will now go back and try to search in the vector space which are the matching documents and come back to you. It will not have the memory to understand that this is a follow-up question. So which is where agents are really helpful. They can understand this question is a follow-up and answer with respect to it. Okay. Then I can also explain you how tool calling works, but I'll not. I'll skip for now. I'll keep it as a activity for you, as an external learning source for you. For now, even following up till adding a conversational memory is more than enough. Okay. So there are certain prerequisites that you will need. You will have to compulsorily run module number 3 and 4. Okay, assuming you might have run it till this point, because see, each of my notebook has some dependency on the previous notebook. Okay, so the way this project is supposed to work is that you have run through module number 1, 2, 3. You cannot jump in between. Even if you want to jump, at least run these notebooks once, so that vectors are created, the files are populated. Okay, and then you can run through it. That's it. Google API is always needed if you are working with Gemini. Along with it, these are a few things that you need. If not, they're mentioned over here. If you do not need it, comment it out or run through it. Okay, things are very similar. Now we will just simply load our indexing and the vector store. So directory, load vectors. Okay, once it is loaded, load the Gemini key. Same module, which is the Gemini backend, we are using it. Okay, from LangChain document, we are using the same functionality to embed a query, search this query in the vector space, and retrieve documents matching it. Okay, this is it. See, I told you, the more you pay attention, things will become a little easier. By module 6, I'm pretty sure your confidence might have boosted up a bit that, okay, I know what these functions are doing. Embed query is embedding my question into vector space. Searching is matching this query into the available vectors in our vector space. And retrieving is getting back which queries match it. Okay, that's the idea. Now, with that being said, the next idea is that how do we set up LLM? Straightforward. I explained it previously. You just need to write this code if you're using Gemini. Write this code if you're using OpenAI. Now, once this is done, this is where module 6 starts, actually. Okay, we will be using a conversational memory buffer, which is a built-in method of LangChain. Sir, in day 3, please write a bit of code for the small AI chatbot creation. Then we got an idea about how the code will be working. Definitely, I have taken this input. I'll make sure that I start day 3 by writing a small code and explaining you how it works. Okay, I'll do a live hands-on writing of the code. Don't worry. Okay. So now, with that being said, the idea over here is that what is this LangChain memory all about? Okay. So see, the LangChain memory is useful to keep the previously asked questions and previously answered questions into a temporary memory of the AI. Okay. Whereas prompt template is similar to the previous module that we just need to design a template out of it. Okay. So memory is a variable which will store the memory, and it is a chat history, and returning message is also stored with it. Okay, that's what it says. And we will condense a prompt which is like system. This is a prompt template. System kya hai? Give a conversation and a follow-up question. Rewrite it. This is the prompt. Okay, we will pass the chat history. At the very first time, it will be empty, and there will be a follow-up question, and then there will be a standalone question. This is our template. Okay, which we'll be using. Now we will convert the messages into string and we'll put it into a prompt template. Okay, so this is the idea of how the memory is supposed to work. Now with this thing, let us see how we can generate an answer out of it. Okay, so in order to generate an answer out of it, okay, what we'll have to do is we'll have to pass a message into the prompt template. Okay, so you are a concise assistant, you provide an answer. If there's a question, use this context and answer it. Okay, so these are same from the previous sessions, that you can format the document and you can answer with the context. Okay, now chat function with memory has this methodologies to work with. You condense with history, which is very first thing that you do is you warm up your agent with what is the conversation which is happening. Okay, so suppose if we have asked a few questions in the previous steps, it will tell the agent that, hey, this is the current conversation which is happening. Along with it, it will retrieve from vector space, answer it, and then save the answer. Along with giving you the answer, it will also go back and condense the answer into the history. Okay, that's how it will work. So see, first of all, we are condense questioning with history, and then we are retrieving it. So what does it mean? Suppose if I'm asking that, hi, how are you? If this is my question. So condensed question with history, what it will do is, if memory chat is available, it will try to put this in the memory chat, okay? So that the model is now aware that there is some history, and now this is the question. If not, it will directly ask the question, okay? Now, Sumit is saying this is understood, okay? Then the docs will retrieve the whatever chunks are needed for this particular question now. The answer will then answer with context, and memory will then save it for any follow-up questions. And this is a cyclic process. This is how the chat will work. Question aayega, it will check the memory, it will go to the retriever, it will answer it with the memory and the retrieved chunks. With the answering, it will also save it now for the next follow-up. So this is it. So see, I have created a small conversation right over here, okay? Idea is, what is HDL? And if you look at the second question, there is a similar abbreviation starting with L, okay? And if you see, the second question in itself will not make any sense, because LDL is something that it's supposed to answer, okay? And which is bad for heart. So if I just ask you this question itself is not complete. But if you look at the follow-ups, it will try to make sense, okay? That, okay, previously I answered what is HDL, and now it is supposed to mean that this user is asking what is LDL, okay? So let me run through this once. I'll run through each of this project in the live memory. Let me run this code, okay? Where are we? Okay, the code is running still. Okay, it has run through this part. Okay, it has now it is running through this question. Okay, so what is LDL? It is giving me an answer. LDL is a high density lipoprotein. My question is, there is similar abbreviation starting with L. So it is answering me because it removes cholesterol and arteries. Okay, so this is not a factually correct answer. This is where the LLM has failed, but which is bad for the heart. So it is trying to answer me with respect to the HDL and LDL, that which is bad for the heart. Okay, so this is again a good follow-up thing. If you see, I'm also printing you conversation history snapshot. First question was what? What is HDL? What is the AI answer? This is the AI answer. What is the next question? There is a similar thing coming up. And what is the AI answer? You see with the dot over here, they are supposed to take up the memory. Okay, and this is the follow-up. The complete output I'm printing in the output. Okay. This is it. This is all about it, and this is how it's supposed to work. So I have used a reactive style agent, and this is a built-in exercise for you people, where I've tried to show you how function calling can work. Not a part of this syllabus, but I've tried to enrich the function with many more learning lessons that you can take up. Okay, so this is the idea about it, how a multi-step agent can work. So after completion, of course, क्या ये recording available होगी? Yes, this recording will always be there on YouTube. Okay, it's like a YouTube video that will be available forever. Only benefit of being live is that I am right now over here, just 10 seconds ahead of you. So if you ask me any questions, 10 seconds के lag के बाद it will come to me, and I can answer it as until and unless I am live over here. Okay. So let me check, people. We still have 10-15 minutes more, but this is the idea about how we can create vector spaces and use it with the agent. Now, for day 3, one request is coming in that, can I create a small script which I will write line by line and explain how the agent is supposed to work? Yes, I will do it for day 3. Any other requests that you have for day 3, or any doubts or any problems you might have faced while cloning this repository, or anything you want to ask, we are all up for the chat, people. Let me check if there is any question coming in. Okay. Yes, ये तो बेस्ट है, क्योंकि समटाइम्स प्रैक्टिस के दौरान कुछ समझ नहीं आता तो लेक्चर रिवाइज कर सकते हो. Yes, yes, of course. That's the best part of it. Okay. Any more question, anyone? If not, I think we can stop the session here. Yes. So day 3 will be how we can we will try to create a simple UI with Gradio app, okay, where we can upload a PDF and ask questions around it, okay. That's what we will do. So what I will do is day 3, I'll try to make it a live code, okay. Can you just provide module 3 IPUNV from yesterday's session because I missed that one to download. Oh, I have given you module 1 to 6 all in the this all-in-one document, okay. So if you simply try to open it up, all-in-one documents, okay. Let me open up that all-in-one document for you, okay. So in my phone, if you see all-in-one documents, right over here there are resources, and I can see this Git repository. This Git repository, you can simply click it. This contains everything, okay. Module 1 to module 6. All right, any other question? If not, we are good to go. You need to be a little more specific, Shubham. What do you need to know about LLM models? Because LLM models start off with the concept of transformers. Do you understand what is encoder and decoders? How the query key value works? What is the concept of these things? Because this is the bare basics from where you can start talking about LLM models. Or is there anything specific you want to talk about LLMs? So I hope, Isha, you were able to find the all-in-one document and the Git repository, which contains all module 1 to module 6 notes updated over there. You can follow me on LinkedIn. You can ask queries. I'll be able to more than happy to answer you over there. All right, I think that's all for today, isn't it? So have a lovely evening, people. Thank you so much for joining in. It was really interesting to teach this session along with you, right? LinkedIn profile name, you can always search it with my name, Jaurav, something like this. This should be the name that you will be able to find on LinkedIn. Okay. Thank you so much, people, for coming in live. I'll see you all tomorrow. Tata, bye-bye, good night, sayonara.